Hello, welcome to the course Exploratory Data Analysis for Data Science with R software. So in this first lecture, I want to give you some basic information or basic idea what is really expected from data science. Data science is relatively a new word that was coined a couple of years back, and before that it was only statistics, but somehow statistics got a new structure, new definition, new expectation, new things, and people started preferring data science. So what is this really data science is, and what is expected from data science which was not expected from statistics, and what really happened that statistics got a new cover as data science. So this is what we are going to understand in this lecture. So let us begin our lecture and try to understand this very simple concept, and this lecture is going to be something like a storytelling which you have to understand before we start into data science, what exactly we want to do and what is expected, for which we have to use the proper statistical tool. So that is why this lecture is more important for us. Okay, so let us begin our lecture. So now in this course, in this lecture, we are going to understand about data science, why, what, and how, right? So in case if I ask you, what is data science? But before that, the first question comes, what is science? Because data science has two words, data and science. So what is here this science? So it is a special approach to find the answers of a query. Many times as a human being, we always want to know the answers of a specific question. For example, why sky is blue, right? Why the air is blowing, how the rain is coming, etc., etc. And for those questions, we want to know the reason. Like we want to know how, why, where, who, whom, etc. And in order to understand the answers of this question, we need the data. What is data and why data is needed? Data is a very reliable source of information, and this data contains very reliable information inside it. But the problem is this data cannot speak. Data has a special language, and we need to understand that language so that we can retrieve the hidden information which is contained inside the data. So what is data science? This is a scientific approach of retrieving the information from data, but this is the same definition what we used to give to the statistics, but the same definition continues for data science also. How? That we will try to understand. The first question comes here, whenever we want to find out the reason, why do we need the data? Why can't we find out the answer without using the data, right? For example, if I give you a very simple example that in your class, if I want to classify the students into say grades like A, B, C, D, etc., and if I say all those students who are wearing a blue shirt, they will be getting a grade A, those who are wearing a say black shirt, they will be getting a grade B, and so on, I'm sure that you will not accept this rule. But on the other hand, if I ask you that anybody who is scoring more than 80% marks will be given a grade A, and all those students who are getting the marks between say this 60% and 80%, they will be getting a grade B, you will very easily accept it. So if you try to see what is the difference between the two, the difference between the two is that we are trying to make some logical reasoning for taking a decision. So this is what we mean when we are trying to take a logical decision which is acceptable to everyone. Now the question is this, how you can take the logical decision. So for that, the most simple option is that we can collect the data. So why should we collect the data? To quench the thirst for the knowledge, because we want to know the reason, how, why, where, who, etc. And the easiest option to get the answers of such relevant question is to get some data, and this data should be related to the relevant question. That means it should be like that if I want to know the average height of the students in a class, then we have to collect the data only on the height. We should not do that. We collect the data on the weight of the student, and we want to know their ages, right? So then we try to answer all the questions on the basis of this collected set of data. So that is why this data is an very important ingredient in the data science. And this data is very important source of information, but the problem is this data cannot speak itself. Data cannot raise the hands like as a student inside the class to ask a question or to tell the answer of a question. So that is why we also cannot understand what data is trying to tell us. So we take the help of statistics. Statistics is the language of data, and it consists of different types of tool which helps us in understanding what data wants to convey about the information hidden inside it, right? So how to collect the relevant data, how to analyze it properly, and how to draw the correct statistical inference from the collected data, how to decide for the correct statistical tool on the numerical fact, all these things they are referred to as data analysis. And statistics is a science of turning data into information which can be used for a decision making. Only getting the data or only analyzing the data, whatsoever outcome you are going to get, you just look at the outcome will not help unless and until you transform the relevant information into a good decision making. So that is a job which statistics and data science do. And it is very important for us to understand that whenever we are collecting the data, we are implementing some statistical tool. After that, we are getting either some numerical values or some graphics. But the proper interpretation of those statistical inferences is very important. And remember one thing from my experience, I can share with you all that statistics cannot do miracles. Statistics cannot change the process or the phenomena. For example, many times some people suppose comes to us and suppose they have conducted an experiment on some new type of medicine, and suppose they ask me that can you prove that this medicine is better than the earlier medicine? My answer is no, I cannot prove it. But my answer is, although I cannot prove it, but definitely I can find out whether this medicine is better than the earlier medicine or not. That means there are two possibilities. Either the medicine which you have developed is better than the earlier medicine, or the second option is it is not. So I can tell you which one is the correct answer. But I cannot force to do something which is actually unethical to prove that the current medicine is or the new medicine is better than the earlier medicine. Right. So statistics cannot change the process or the phenomena. Whenever we are trying to conduct an experiment, the experiments are conducted in the natural way. Right. Whenever we ask any question to a group of people, they are going to reply in the way they want. I cannot ask the group of people to reply in a particular way or in a particular fashion or try to give us a particular type of answers only. So this statistics is a scientific way of extracting and retrieving the information. So now, why should we collect the data? To verify the theoretical findings. Many times there are some rules, some hypotheses which we try to prepare on our knowledge, and we want to verify whether those relationships are existing in the real phenomena or not. So we try to collect the data on that phenomena and we verify whether those relationships are holding true or not. Then we try to draw the statistical inferences on the basis of the collected set of data. And you know that then we try to develop, based on this actually we try to develop different types of statistical models which are further used for policy decision, classification, forecasting, etc., etc. And this is all we try to do in the this data science, right? So I would like to give you some idea about the data and the use of statistical tool, right? I have seen from my experience that sometimes people try to criticize statistics and they try to make different types of they say jokes about statistics. I have no issues with those things, but then we have to understand that in case we want to use the statistics on some data, what are the rules of the game? So as we have now understood that statistics is a language of data. So now suppose we have some objective, and based on that we try to collect some data. Now there are two possibilities. The data can be correct and the data can be wrong. Now based on this data, suppose we want to retrieve certain type of information. For example, if I want to know the average age of the students in a class, that means we have to collect the data on the age of the students. Now after this we have to use some statistical tool. For example, if I want to know the average age, for example, this arithmetic mean can be used to find out the average age of the students. So suppose I have two options here. Suppose I use arithmetic mean or I use the correlation coefficient. So that means one tool is correct and say another tool is wrong, right? So now the use of a statistical tool can also be divided into two categories. The statistical tool is correct or the statistical tool is wrong. Now, when we are trying to use the wrong statistical tool on the wrong data, then what will happen? The decision is going to be incorrect. Second option is this: I am going to use the wrong statistical tool on the correct data. Even in this case, the decision is going to be incorrect. Third option is that I can use the correct statistical tool on the wrong data. In that case also the decision is going to be incorrect. Now, if you try to see out of these four combinations, three are giving us the wrong decision. But when we try to use the correct statistical tool on the correct data, then it gives us the correct decision. So out of these four possibilities, there is only one combination which is going to give us the right decision. So this is what you always have to keep in mind, that if you want to know the correct statistical result, then you have to use the correct statistical tool on the correct data only. In case if you try to use any other combination, either the tool is correct or the data is incorrect, then your decisions are going to be incorrect. And this is what generally people don't understand, and they try to make jokes of statistics. Well, that is your choice how you want to take it. And the rule which I want to tell you is very simple: garbage in, garbage out. That means if you give the garbage input, your output is also going to be garbage. And statistics has its own derived rules. You will see that whenever we want to do something based on that, we have to use some mathematics to derive the rules, and then we try to use it. And these rules are framed in such a way that the correct decision as indicated by the data and based on the hinder information are taken. That means as a human being, as an experimenter, we can observe some phenomena, and based on that we try to take a decision. For example, if I say, if somebody observes that the clouds are black, this indicates that there is a high probability or there are high chances of rainfall. So the advice is that before leaving your house, please carry an umbrella. So if you want to do the statistical modeling of such an event based on the data, means clouds are black means that there are some values of about humidity, pressure, air velocity, wind velocity, etc., etc. So you try to collect the data and you try to do some statistical analysis which should forecast that the presence of black clouds is going to indicate that high chances of rainfall are there. If this is not happening, so that means there is something wrong in our assumption, in our analysis, and the type of modeling what we are trying to do. So we have to review it. And in fact, if you try to understand, the statistical modeling cannot be obtained in a single step. It's a recursive process because we are trying to model something which is unknown to us. and the control is only in the hands of God. We are trying to make a statistical model for a very complicated phenomena. So usually we start with some data, we try to use some statistical tool, statistical modeling, and then we try to verify it, whether this is really happening. That means whatever my statistical tool is giving me the outcome and whatever is happening in the real life, are they matching? Then my statistical model will become a good model. So our statistical model also, for example, does forecasting, but it is not like an astrologer's parrot, but they are based on some mathematical background and based on some scientific concepts. Right. Now, this statistics was doing well, but suddenly this statistics, or gradually I will say statistics, got transformed into data science. So what really happened? Why this happened? And what was really expected from data science which was not expected from statistics, or what was there in data science which data science could fulfill but statistics could not fulfill the expectation? What really happened? So if I try to explain you, in early 90s when the computers started coming, at least to India, I know. Before that, we used to do only calculation either manually or using some calculators. And the data was also not so easily available. Earlier, the concept which we used to know was that if the data size is more than 30, then we will consider as a large sample. Although this was also based on the concept of normal distribution and t-distribution. So, doing calculations with calculators was not always possible if the data size is too big. So then gradually the development in the computers started happening, and after some time the development in the computer science and computers was quite rapid, and this impacted the statistics also. Earlier it was difficult to collect the data, and many times the data was also not available. Now if you try to see, data is very easily available and too much data is available. For example, if I say those people who are using the smartphones, lots of data from the smartphone is being transmitted to different applications. For example, Google. If you try to see, the Google Maps are used to know the route on which we want to travel. So this is also based on the data what is being transmitted from different say phones. And every second you can imagine that millions and billions of people around the world, they are emitting the data, and that is getting stored in some servers. Some algorithms are trying to compute the route and the locations, and then they are immediately transmitting on your phone. So if you try to see, with the advent of new technologies, the collection of the data becomes very easy, and now the size of data has become too large, and the concept of big data analysis is now there, and petabyte is the unit of the data size. So this is how the growth of data took place. Earlier, the emphasis was mostly on the theoretical developments in statistics, and there was some valid reasons also, because when we are trying to analyze any problem mathematically, after certain steps, the algebra or the mathematical details used to become so complicated that it was not an easy job always to solve them further by everybody. But then in this case, the computers actually helped, and they helped in the computation of different mathematical steps, and this led to the development of computational statistics. So if theory and mathematical analysis become complicated, then the computational statistics came forward, and it helped and it supplemented the research and the new developments. And with this computational support, the theoretical developments in statistics gained more relevance and applications, and people found a way that even if the mathematics is becoming too complicated, their computations can shed some good light in the information which is hidden inside the data. And finally, the computation and the statistics became two inseparable parts of data science. This is how these things actually develop. And once we venture into this computational statistics, then we can understand the role and use of computers become very important. And when we are trying to store the data into computers and we want to retrieve the data from the computers, we want to implement that data on some statistical tool which are based on certain mathematical logic, mathematical functions, mathematical programming. Then we also need to know the programming language. So whenever we want to take the help of computers, then we require to know the programming language. We need to have a good knowledge of the software, data management, and some other aspects. The idea is only one, that data is coming directly to the computers. The data has to be supplied to the statistical tool. The computations will be done automatically, and the outcome will also be diverted to the computers, and the computer has to demonstrate it in such a way which we can understand it easily. So the areas of application of statistics really increased tremendously after the good use of computers, and the topics like artificial intelligence, machine learning, supervised learning, unsupervised learning, reinforced learning are being used, which are purely based on statistics. But they also the use of computers, and they heavily depend on the use of computers. That means you need to have a good knowledge about that how you should use the computers. So if you try to see, when we are talking about the data science, so data science is not consisting of only one topic or one subject, but it has various ingredients: statistics, mathematics, computer science, and many others also. The objectives of statistics and data science are the same, right? As we discussed in the beginning, whatsoever are the objective of the statistics, they are the same in the case of data science also. The statistics aims to extract the information contained in the data, and so is the same aim of data science also. But the advantage is that with the data science, we can apply the statistical tools in many more areas than the statistics alone. The collection of data through different gadgets has become easier, and there is always not the need of human being going to the field to collect the data. The electronic gadgets are also helping in the collection of data science. So data science, when applied to different fields, can lead to incredible new insights. One thing what we have to understand, that in decision sciences, because the data is being collected by different types of electronic gadgets, the only form of data which is getting collected is the digital data. So in most of the cases, the decision science is using the digital data. The digital data is information that is not so easily interpretable by an individual, right? It depends on machines to interpret it, to process it, or to change it. For example, what we see on a computer screen, that can be a text, that can be a photo, that can be a movie, etc. They are all the digital letters, which are essentially they are arranged in a systematic way such that they give you the impression of a text, photo, or a movie. And this digital letters, they are coded as zeros and ones. So now we have to understand that this text, photo, movie, etc., they are also the sort of digital data, which is a collection of coded zeros and ones. So now, in order to understand, in order to read it, we definitely need the use of computers. So now if I try to ask you a very simple question, after giving you all these ideas, what is really needed to become the data scientist? Yeah, first thing I can very honestly tell you is that you have to first decide what you want to become, a doctor or a compounder. Both are important, but then they have got a different role. The doctor is the one who takes the decision what medicine has to be given out of thousands of medicines, and the compounder simply follows the advice of the doctor and gives the right medicine from the collection of the medicine. So many times I have seen that people are using the built-in programs, different types of algorithm which are available at different places, either paid or unpaid, and they are trying to use it in their data and they are trying to give us the outcome. I am not against it. That is good. But then my objective is that if you want to solve a new problem, and for that you have to develop some new tools, then for that we need to understand the basic fundamental of the sciences, particularly statistics, mathematics, computer science, and something else. So first we need to decide whether we want to use only the tools, we want to understand the utility of the tools only, or we want to develop the new tools, right? In my opinion, all are needed, right? So in case if you ask me from the statistical point of view, what exactly you need to learn, the list is very long. You need to learn the descriptive statistics, probability theory, statistical inference, decision theory, Bayesian inference, frequentist inference, parametric inference, non-parametric inference, multivariate analysis, linear regression analysis, non-linear regression analysis, simulation techniques, Monte Carlo methods, and there are many things. Okay, I'm not trying to scare you, but these are the things which you need to know from statistics so that you can apply those tools in computer science. And I'm not trying to say that whether which subject is more important than the other. All the subjects are equally important data science. Why? Because the theoretical developments are essential which are needed to be exposed to the computational procedure. For example, if you want to know the answer of some question, so first you need to understand that how we have to develop the tools, and for that you have to use some mathematics. When the tools are mathematically correct, then only you can be confident that the outcome given by those tools are dependable. For example, in the beginning I asked you a simple question that if I want to give you the grades A, B, C, D, etc., then either I can give you on the basis of the color of the shirt or on the basis of the examination marks. And you agreed that, okay, the marks is a better criteria which is acceptable to everyone. So if you try to see, I'm just simply trying to use some mathematics behind it. I will try to give you several exams. I will try to take your examination copies. I will try to give you some scores, and then I will try to take the total of all the scores like as quarterly examination, half-yearly examination, unit test, etc., etc. Right. So that is why these theoretical developments are very important. Now, when we are trying to discuss about the computational procedures, then computational procedures also have their own limitation, and to resolve them, the optimization methods are really important. For example, if you want to invert a matrix of 3 by 3 order, then you can do it manually. But if you want to invert a matrix of say 1 million by 1 million, then you need certain optimization techniques. So the implementation of statistical, mathematical optimization methods, etc., are to be simultaneously implemented over a data set. They all have to work together, and for that the data management is required. So all these aspects are logically implemented in a systematic way, and then the correct statistical inferences are drawn. And this is the objective of the data science. And based on the obtained inferences, the proper interpretations are made and used for policy formulation, policy prescription, and further applications like forecasting, etc. So without learning the basic tools of statistics, it is not possible to learn data science. So the proper knowledge of all the fields is required to become a data scientist. Well, I'm not saying that you need not to learn the knowledge on computers, but I am trained only in statistics, so I'm trying to emphasize on statistics, but the knowledge on all other aspects is equally important and which is needed. So now the next question comes here: what is my role and what is my job? So now if you try to see, my role and my job is very simple. Means I know statistics. So I want to expose you with the basic tools of statistics which are used for the exploratory data analysis. That means first, hand tools. Whenever the data comes before you, what you have to do the first thing with the data, and then how you are going to interpret it, how are you going to compute it, how are you going to understand it. These are the things which I want to tell you here. And then I want to make sure that these tools are important for the data science. I cannot teach you all the aspects of data science in this lecture, but the statistical aspect of the data science I will try to teach you here. Definitely, you also have to keep in mind there is a long list of the statistical tool and different types of concepts which are needed. And due to the limitation of the timings of this course, I cannot cover all of them. But surely, I will try my best to take out the fear of learning statistical tools for data science from your heart. And for that, I need your help also. We need to hold the hands of each other. We need to follow the advice. Whatsoever based on my experience, I will try to give you some pieces of advice which might be helpful for you in learning the data science. So in this lecture, I have given you a broad overview of what is exactly is data science and what is expected from data science which was not expected earlier from statistics. So this will give you some food for the thought. Well, these are my own personal views, and this is how I think about data science. Right, so you try to understand it, try to read from different sources what others says, and try to make up your mind that how do you feel the data science should be? How do you think what data science should do? And you try to explore them, and I will see you in the next lecture. Till then, goodbye.